You have seen this article very recently. This was in news. So, win Nobel in quantum computing, get Rs 100 crore. Andhra Pradesh CM to researchers. So, are you ready? Especially those who are from Andhra Pradesh. So, first of all, let me clear you. This is not a fake news. This is the true. It has been announced by our Chief Minister Chandrababu Naidu. So in this session, we are going to talk about everything from scratch about the quantum. So before going ahead, let me tell you the historical insights is always the foundation of future innovations. So let me talk about the facts of the history. So Sir C.V. Raman has already won the first Nobel Prize in this field for his discovery Raman effect, that is modified scattering of the light. So he has proven that the photon and molecules exchange energy, a key concept in the quantum mechanics. So the field was related to the quantum only. So your history is bright. Now it's your turn. So I welcome you all to the Spark Research YouTube channel. This is Dr. Veer Chandra, Assistant Professor in the Department of ECE. We are running in this COMSOL Research application, and in this session we are going to talk everything about the quantum science and the research, that how can we do and exactly how can we use this COMSOL platform to do the research related to the quantum science. So before going ahead, here is SRMIST, which is ranked on the 14th as per NIR of 2025. Now, if you remember the question that I have asked in the previous session, did you remember? So question was, is mass quantized? So did you got the answer for this question? If you got, then definitely we are ready to start the topic, that is quantum, right? So answer, like in the session also I have given the hint that neutrinos have the smallest mass that we have found till now. That is the mass is almost 10 to the power minus 36 kg. So now let's talk about the quantum science. So what is this? So STD is nature at the smallest scale, right? A scale is your level of atoms, level of electrons, level of protons, level of photon. These are the things we are going to talk in the quantum mechanics, right? So whenever your quantum science will start, there your classical physics will not be valid. So all the rules of the classical physics will stop to work. Then your quantum science will start to work, right? And why is it so? Because of the smallest particle in the natures. So right now, if I will ask that, have you visited jewelry shop? Definitely you may have seen the 1 gram, 2 gram of the gold, and the cost of even the 1 gram right now, I think maybe the 14,000, 15,000 of 1 gram gold only. So can you imagine the weight of the 1 gram? So very less. But we are not talking about the gram even. We are talking about the nanogram, picogram, femtogram. So how small are we thinking? Can you try to visualize? So we are, the mass of the electron is 10 to the power minus 31, right? Means not nanogram, picogram. So very much lesser, and less weight. So we are talking about that type of the particles, right? So how can we think that the classical physics rules will be valid there? So of course not. So here, because of the small particle, your particles will act like wave, right? Means your particle may not be acts like particle and exist in the multiple state at once. So these are the two special qualities of the small particle like electron. That is why we are talking about this quantum science, right? So quantum science explain how matter energy behaves at atomic and subatomic levels. So this is the primary objective to learn. So let's start from the beginning in the history. So first discovery of electron has been takes place by the J.J. Thomson in 1897 using the cathode ray experiment, right? Later, by the Milliman oil drop experiment, the Milliman has found the quantity, that is the charge of the electron, that is 1.6 into 10 to the power minus 19 coulomb, right? So in this year, means till 1909, we have all the information about the smallest particle of the atom, that is your electron. But still other parts are unknown. So Rutherford performed experiments related to your gold foil experiment, where just he bombarded the alpha particles with high speed, and he found the nucleus of the atom. Later also in 1919 he found the proton as well. So in this way we have the details about the nucleus and the protons, and Bohr's also modified and found the atoms. So everything's about the atoms. Later your Max Planck has also introduced the energy, demonstrate that the energy is the quantized, and can also be found as a is equal to nh nu. So this rule has governed by the Max Planck. So with the help of this equation, now we are able to introduce the quantum mechanics. So till here now, the we have the information that energy can also be related with the frequency. Okay, so later photoelectric effect has been introduced by the great scientist Albert Einstein in the 1905. Here they found that the energy can be transferred from the photon to the electron, and similarly electron can also emit the energy, right? And so a quantum energy is equal to h nu by phi, and that is why your the solar cell is working nowadays using the photoelectric effect only. And later de Broglie in 1924 has found that okay, all the particles may have the dual nature, particle nature as well as the wave nature. So this is the groundbreaking the discovery. Why is it so? Because the Einstein told that it have the particle nature, and then someone told like they have the the wave nature. But here now Broglie hypothesis that okay, we have the particles will have the both nature, particle nature and the wave nature both. Okay, how can we understand that it have the both nature? Let's have a one very simple experiment. Experiment is your double slit experiment, Young's double slit experiment. So here you can see there is wall, there is small hole. You can switch on your torch light source. So of course, if there is two holes, so double slit is here. So what will happen? Light, like what Young's has observed, that light is not like stopping here or coming back, but light is able to pass from this hole and this hole, and then you will, you will found that superimposition principle, like, and then you can observe the some light intensity like that, right? After the interference on this fluorescent screen. So what is the challenge? Challenge is that since suppose instead of the light, if this is an electron, then what will happen? Your electron either may be at this position or this position. But is it possible to found electron at this position or this position at the same time? As per classical physics, it's not possible, but in quantum it's possible. And again, suppose there are 4 hole or 8 hole, 16 hole, then your electrons may have found at any of these states. So that is why, and once if you found your electrons at this state or this state or anywhere at any state, then automatically the probability of you to find your electrons at other states will be vanishes, and you will got it here. So that is the exactly the your the natures. So you can find your particles. and also electron have the wave nature as well, so electrons should also follow these patterns. So as per the the dual wave particle duality natures, your particles can be converted. Your particle can be think as a the wave, and the wave will also follow these type of patterns. So any particles can have the same type of the propagation patterns, right? So that is also called the quantum entanglement, right? Because if you wanted to find any particle at any certain point, and because of the particles can found at any states, uh, then automatically it will be called as the quantum entanglement, where demonstrating a performed quantum the correlation with each other. So how exactly it works? So two particles always linked, and changing one instantly affects the other, even across the large distance. Here in the double slit experiment, we found the distance is very less, but this will be valid even for thousands of kilometers as well. Why? Because the the it will be correlated to each other always. So how it will be correlated? So particle becomes integral to only when they are created together, that is photon pair, interact and then separate, then share a common quantum state. As for example, you can consider the orbital of any atom. So what is happening orbit in the orbital of uh, any states? Of course, the electrons are moving in a same orbital, having the different spin, opposite spin, right? So total spin, that is plus half minus half equal to 0. So this is the one good example of the entanglement, quantum entanglement. Then what are the applications? Of course, your quantum computing. So why are we talking about this quantum computing? Because the you are now computing the different scenarios, right? Your if your bits is 1, then you are computing 2 to the power 1. Your number of bits is 8, then your states computer will compute the 2 to the power 8. So it will have the huge the computational power. So you can it can perform the high number of computational, so that is why it is very useful. Then quantum cryptography, then quantum teleportation, quantum sensing, so these will give the very precise information. So if you want to have the computational if you want to increase the computational capacity, definitely quantum computing is a very important topic. Okay, another principle is the quantum tunneling. So what is the quantum tunneling? Here you can see there is potential barrier, but is it possible to cross if your electrons or any particles have less energy? As per classical physics, it's not possible, but as per your quantum, it's possible. Always there will be the possibilities to cross this state. As for example, let's see the example here. Suppose electron is acts like a ball, and there is a wall or electric field. So of course it will not cross. It will repel by the electric field. Or if you are just throwing towards the wall, it will come back right after the reflection. But in quantum scenario, this is as per the real like classical picture. But as per quantum scenario, what will happen? The electron is not a wave, not ball. Electron is a form of the wave, and always due to the quantum tunneling, your electron can cross the electric field boundary or wall, right? So it can cross. Because of this only your transistor is also working. So in quantum physics, we have the function of the electron, which encounters the electric field, but has the some finite probability of tunneling through, even if it have the less energy. So that is the quantum tunneling. Some application, like you can see tunnel diode, resonant tunneling devices, flash memory, and scanning, tunneling, microscope, atomic level imaging. So these are the important application of the quantum tunneling. Okay, so now coming to the my research area. Uh, the advances in silicon quantum photonics. This is one research article you can find on the Google Scholar, and you can check it. So this paper has already been published in this journal, IEEE Journal of Selected Topics in Quantum Electronics, and published in 2021, written by Ed Koch. And so what is in this article? In this article you can see the some photonic related waveguide, and then the photonic related your aid drop, and this is coupler, some the how exactly, so lithium niobate waveguide, so the coupler and all these things are there. So low loss cantilever coupler is there, details of photonic crystal grating coupler is also there, right? So if you'll go through these articles, then you can find the different types of the the design structures where the primarily the photon is a carrier here. So that is why we are talking about this. So exactly what do you mean by the quantum science or quantum physics? So overall, we are talking about the smallest particle, that is the nature of the smallest particle exists in the world. Then what are the smallest particle? Definitely electron, your photon. So a study of all these particles are comes under the quantum science, right? So that is why these things are also the part of the quantum science. So if you wanted to design these type of structures, definitely we can design on the COMSOL platform, and we have already seen, and also we'll continue to design these type of structures in our upcoming sessions. So if you are interested to design your structures related to the silicon quantum photonics or related to the the quantum optics, definitely you can use this platform, that is COMSOL platform, and we have already started to design and will continue to design, so you can learn about it. Okay, so thank you to join the session. If you have any question, please drop your question.